All right, so we are ready to evaluate some U sub problems. So notice the difference in these questions versus the ones you've had is that you have bounds. So you're going to evaluate. So let's get going. Let's just pretend that that didn't have the 0 and 1. Okay, let's pretend it didn't have the 0 and 1, and I want you to work on seeing if you can do the integration. So hopefully you would think, all right, U is going to be x to the 6 plus 1. Du would be 6x to the 5th dx. So and notice I'm not going to write bounds on this just quite yet. It'd be to the -3rd, and I have x to the 5th dx, okay? So, okay, I'll write these bounds, but I want to be very clear on the next line, because when I do the U sub, this would of course be U to the -3. Now x to the 5th dx is going to be du over 6. So I'm going to put du and a 1/6. Notice that I do not write the bounds there. And the reason I'm not writing the bounds, because remember when this 0 and 1, that's the variable. So if I put 0 and 1, this integral is for du. My 0 and 1 are x's, so I can't put those in until I get it back in x. So I'm not going to write anything there. So if I do that integration, of course, what would I get? Well, increase the power by 1, which is -2. Divide by the new power times the 1/6. Now, normally I would put a plus c, but I know I am eventually doing the definite integration, so I'm not going to worry about the plus c. So I have -1/12 u to the -2. So I'll just, if it's okay with you guys, I'll just put x to the 6 plus 1 squared. Okay, now I have it back in terms of x, and then I'm going to do my 0 to 1. And in fact, I like to pull my constants out, so I'm going to do my 0 and 1 right there. So I'd have -1/12. Now let's figure this out. If I plug in, so I'll just put a 1 right there. If I plug in a 1 for x, that would be 1 squared, or 1 to the 6 is 1, plus 1, that's 2. Are you with me that that would be 1/4? Are we in agreement with that? Minus, if I plug in 0, that would be actually just 1. So what is that? That's -1/12 times -3/4. So that goes into that 4 times. Negative times a negative is a positive, and I would get an answer of 1/16. Cool. There you go. Okay. Now let's do the next one. I want you to see if you can do the next one here. So I'll give you a minute and see if you can get it. Hopefully you let your u be 3x. So du is 3 dx. So what am I really integrating? I'm really integrating, well, sine of 3x would be the sine of u. Now dx would be du over 3. So I'll just do it like that. Notice I don't put the bounds because I have it in terms of u. And so what would I get? I would get, well, what's the integral of sine is negative cosine of u. I have times the 1/3. So again, I like to, let's clean that up a little bit. I'm going to just do I like to do my constants on the outside. So I'm going to put the negative with the 1/3, and then I would have cosine of 3x. So now I have it back in terms of x's, so I can put my 0 to pi over 12. Now let's do it. I have negative 1/3. I'm going to go ahead and write this one out so you can see what I'm doing. That would be the cosine of, well, 3 times pi over 12. Wouldn't that be pi over 4? Minus the cosine of 0. Yes. So I would have negative 1/3. Cosine of pi over 4 is square root 2 over 2. The cosine of 0 is 1. And I'm done. Now here's the deal, friends. Again, doing notes is hard because it's like, okay, is it multiple choice? Is it free response, calculator, non-calculator? I mean, all that kind of stuff. If it's free response, you stop right there. Okay, you stop right there. But if it's multiple choice, you know that they could, goodness, no telling what they could do. They could get a common denominator. So you're like, all right, well, if they get a common denominator, that would be square root of 2 minus 2 over 2. Yes. And then times the negative 1/3. So, or times, so I could write times a negative 1/3. So I would have 2 minus square root of 2 over 6. And they could write it that way. So, I'm giving you answers on your worksheet. So if I go to here, you have to be able to get here. But notice on a free response, you want to do it smart. Learn when to stop. When you get down to multiplication, division, addition, subtraction, all that kind of algebraic stuff, stop because you get full credit for it. So I'd rather you stop there. Now let's look at the next questions. In the next questions, notice they say write an equal integral expression in terms of use. So they're not asking for the full answer. They're not asking for the full answer. They're not asking for a numerical answer. They want an equal integral expression. So what does that really mean? Well, it means it's almost like you're stopping. If I go back to the questions we did before, it's almost like you're stopping right here with one extra little piece. Okay, so let's see. Let's pretend that it says, okay, write an equal integral expression. All right, well, I think you're going to go, I know I would let you, I'm going to write it over here so I can have room to write. Really, that's 7x minus 3 to the 1/2, and then you have an x dx. So you're going to let your u be 7x minus 3. So du would be equal to 7 dx, yes? Okay. And this was from 1 to 2. So let me start doing the u substitution. Well, this is u, so u to the 1/2. Now in this problem, you're like, oh, bummer. This is not one that I can replace all of that. Unfortunately, the dx I could replace. I think you're with me that dx would be equal to du over 7. So I'll go ahead and replace that guy with du over 7. And yes, I could pull the 1/7 out. I'm just doing it in steps. But this x I haven't replaced. There's no way for me to do that. That's when I have to look at this equation and say, well, if I solve for x, that would be u plus 3 over 7. So let me replace that with u plus 3 over 7. And there are my three things. But here's the deal. Notice that in this problem, when we were doing the definite on the other thing, I said, oh, I just don't write my bounds because it's not 1 to 2. I have to, my answer, I'm actually leaving like this. Let me go ahead and do the next line and tell you what I mean. If I did this integral and cleaned it up, because they would, first of all, are you with me that I would pull out a 1 over 49 because I have a 7 times 7? And then I have a u plus 3 times u to the 1/2. So I'm going to go ahead and distribute that out because they would. I would have u to the 3/2 plus 3 u to the 1/2 du. Now hopefully you're with me to there. But here's the deal. Sweet friends, don't write this. I promise you there will be an answer choice that looks like this, and it is incorrect. Because remember, the 1 and the 2 are when you're integrating with respect to x, that's 1 and 2. If you're doing u's and leaving it, because it says rewrite it in terms of u, that means your bounds have to be u's as well. So what I'm going to do is I'm just going to look right here. And I'm going to just do a little t-chart. If x is, I like to do them like on top and bottom like they are in the integral, so 2 and 1. If I plug in 2 for x right here, do you see that that would be 14? I'm plugging it in right here. 7 times 2 is 14 minus 3, u would be 11. And if I plugged in 1 for x, I'll draw it here because you can't see where I'm pointing, that would be 7 times 1 minus 3, and that would be 4. That means my bounds are not 1 to 2, they are 4 and 11. You have got to remember to change the bounds. If you are asked to leave it in terms of u, friends, you have to change the bounds. And that's your final answer. They don't want you, again, they don't want a numerical answer. They want that. That's what the answer choices will look like. So why don't you try for me example 4. So stop the video and see, this is kind of a tricky little fella, but let's see if you can do it. They even tell you what u is. So stop the video and give yourself a shot at it. So I tend to rewrite this. Okay, so u is x squared plus 4. Okay, so du would be 2x dx. Now I'm going to start my substituting. And some people go, I'll go ahead and do my chart, because I know if I'm leaving it in terms of u's, I'm going to have to do that anyway. So my bounds for x's are 1 and 0. So what would be my u's? Well, I'll just look right here. If x is 1, 1 squared is 1 plus 4, so that would be 5. And if x is 0, that would be 4. So when I start changing it to u's, my bounds are going to be 4 and 5. Now let's start the substituting. That should be to the -3. I just caught myself making a silly mistake there. So here we go. That would be u to the -3. So I got that one. Now this x to the 3rd dx. Let me think about that. I go, well, I have an x dx, so it'd be really easy to replace an x dx. Oh, wait. And I also have u is x squared plus 4, so it would be really easy to say that x squared is equal to u minus 4, correct? So I'm going to be clever. I'm going to say, you know what? X cubed dx, I'm going to write that as x squared times x dx. I mean, isn't that x cubed? So I'm not changing the problem. I'm just being really smart in how I write that. So let's do that substituting. X squared is u minus 4. So that comes from x squared. X dx, I'm looking right here, and I'm solving for all of this, and that would be du over 2. Now let me just write that in probably how they would write it. They'd probably pull the 1/2 in front, They have 4 to 5, and that would be u minus 4 over u cubed, du. And that is an equal integral expression that would find that. So, what must you remember? If you're leaving in terms of u, you must remember to change the bounds. Did I write that big enough? And here's what I want you to see. Again, I don't want this to confuse you, but I want to show you, because honestly, I might have done this on my worksheet. I'm not sure when I wrote these answers. I'm not sure which one I did. I get in such the habit because I know so many times they're asking me to leave it like this. I get in a habit of changing my bounds. So I'm actually going to go back, and I'm not going to work these problems again, but I'm going to do one of them and go show you an option. Because if you see it on my paper, I want you to go, not go, what the heck is she doing? If I am solving for the actual number, I'm so used to changing my bounds that I do that in this line. Are you with me that if I were to change my bounds on this first one, x and u, 1 and 0, like we just did, here's my equation. So 1 to the 6 plus 1 would be 2. And then if I plug in 0, I would get 1. So if I wanted to, I could write, if I put this with bounds, I could write it like this, correct? Which means when I integrated, looking at this line right here, I could get 1/12 and 1 over u squared. Notice if I've changed the bounds, I could technically never put it back in x if I chose to do it that way. So I'd have negative 1/12. Do you see I would get the same thing? 1/4 minus, plug in 1, 1, and notice I'm exactly the same spot as I was. So some people like that. They like, oh, if I'm going to change it to u, I'll go ahead and change my bounds and I'll never put it back in x. Some people do not like that at all. They're like, nope, if I'm doing definite integration, I'm going to put it back in x, not worry about changing my bounds, and I'm just going to go from there. Either way is fine. Again, I just want you to understand what I did. If I did it this way, I kind of prefer that way, just because it looks a lot less complicated. So I like that, but you can do it both ways. So I just wanted you to be aware of that. If you're doing definite integration, you can change the bounds and never change back to x. If you don't like that, then don't do that. But here's the deal. Don't you dare right here put 0 and 1. Okay, because if you were doing free response, they would take off a presentation point for that. And I will too, because that's not a true statement. So if you're doing it in terms of x, make sure you don't put the bounds on there when you're writing the u's, and only put the 0 and 1 when you are going back to the x's. All right. Well, good luck on that, sweet friends. Peace out.